Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 6.8 entitled Graphing Linear Inequalities in Two Variables. And what we're going to do today is we're going to figure out if an ordered pair is a solution to an inequality, and then we're going to graph inequalities. Now the linear inequalities that we're going to see today are going to be lines that have slope to them, or they could be horizontal or vertical lines. And the line might be solid or dashed. And then we also have to shade above or below the line. Now above and below are in quotes here because it's not traditionally above or below. Now if you have a horizontal line, it's really easy to tell where above and below that line is. So if you were shading below that line, that's really easy to figure out where the below is. But sometimes you have a line with slope. So if you're trying to shade below that line, it's not really below it, it's kind of to the right. Or if you have a vertical line, below the vertical line would be everything that's smaller than whatever this value is on the x-axis. So you're actually shading to the left. So above and below are general terms that we're going to be using. But we're going to solve our inequality for y, or sometimes x if it's a vertical line. And then we'll graph it using our knowledge about slope and y-intercept and horizontal and vertical lines. The kind of line that we make is just follows the same rule that we used for when we do circles. If we have a less than or a greater than, we used an open circle on the number line, so we're going to use an open line, which we draw with a dashed line. If we have that equal to in our inequality, then we would make a solid circle on the number line. So now we're going to have a solid line. And to figure out if we shade above or below, we're going to look at the actual signs. If it's greater than in any way, that represents the above concept. If it's less than in any way, that represents the below concept. And you can always test a point to see if it lies in a shaded region. The shaded region is where you want to be because that's where your solutions are. So if you take a point, an ordered pair, and you put it into the equation, and it ends up being a true statement, then that means that it's in the shaded region. If it's not in that shaded region, then it's not a solution. So that's the skill that we're going to practice first here. So let's take a look at part A. They want us to check whether or not the ordered pairs 0, 0, and -1, -1 are solutions to x plus y is less than or equal to -2. So we're going to test both of these. So let's test 0, 0. So I would have 0 plus 0 is less than or equal to -2. Well, that's 0. Now 0 is less than -2, but it's not equal to -2. So no, that's not a true statement. That ordered pair, 0, 0, would not be in the shaded region for that line when we graphed it. That's what that means. And if we try -1, -1, I'd have -1 plus a -1 is less than or equal to -2. Okay, so -1 and -1, that's -2, less than or equal to -2. Now, -2 isn't less than -2, but it is equal. So yes, that's going to be a solution. For part B, we have to try 0, 0 in a different equation now. So 3 times 0 minus 0 is less than 3. So that's 0 minus 0 is less than 3. So 0 is less than 3. Yes, that's a true statement. And then -1, -1. 3 times -1 minus a -1 is +1. It's less than 3. So that's -3 plus 1 is less than 3. So that's -2 is less than 3. Yes, that's a solution. So again, remember that solution When you get yes that it's a solution, that means that that ordered pair is in the shaded region on the graph. So when you're trying to figure out where to shade, you can test a point. You can pick any ordered pair you want. Pick an easy one like 0, 0, or 1, 1, or -1, -1, 2, 2, or -2, -2. But pick something that's clearly on one side of the line or the other, substitute it into your equation or your inequality, and if it gets you a true statement, then that is where you want to shade. You want to shade where that ordered pair came from. Okay? All right, so let's take a look at some graphs now. And we may need to use that concept of figuring out where to shade by using a test point, like we just did in example 1. So for example 2, it says to graph the inequality, and A and B are meant to be nice. They're horizontal and vertical lines. If you remember for part A, X marks the spot where I stand up straight and tall. So this is going to be a vertical line, and it's going to go through -3. So here's -3 on the x-axis. That's where I have to go through with my line. Now I have to look at my sign to tell if I need a solid or a dashed line. Since I have that equal to, I'm going to need a solid line that goes through x at -3. And then when I'm shading, I have greater than. So that greater than means above. So that means I want to shade everything above -3 on the x-axis. So that's everything to the right. So the whole right side of my graph will be shaded. And when you shade the whole area. If you want to use colored pencils or highlighters or markers, that's fine. You can do that too. Now part B is y is less than 2. Remember, y am I laid out when I slip and fall? So that means it's a horizontal line. So I'm going to go to 2 on the y-axis. I'm going to have my horizontal line that goes through it. But again, I have to look at my sign to figure out if I have a solid line or a dashed line. Since it's just less than, I'm going to use a dashed line. And less than is really easy to see with the belowness. Less than means below. Since it's a horizontal line, that's really easy to figure out where below the horizontal line is supposed to be. So that's where I want to shade. Okay, now for part C and part D, we might have to do a little work first for these. We're going to have to solve them for y. So for part C, I'm going to have to subtract the x to the other side. Now I still have a -y is less than or equal to. I want to put the x first and then the 5 so that it's in proper slope-intercept form. And then I have to divide everything by a -1, so I get rid of the -1 in front of the y. So I'll have y. Now when I divide it by that -1, that means I have to flip my inequality sign. So greater than or equal to x minus 5. So that's my slope-intercept form that I'm going to be using to graph now. So I'm going to start at -5 for my intercept. I'm going to go up 1 and over 1 for my slope. And you can make as many points as you want to make. You can make them go all the way across the graph, or you can just make a few. Then again, look at your sign to figure out if you need a solid line or a dashed line. We have this equal to, so I need a solid line. And then it's greater than, so I'm going to shade above. Now, sometimes students get a little confused on where the above should be. So think of this line that if you could rotate it and flatten it out, it would, this bottom part would kind of move up a little bit. Oops, sorry about that. And if the line was horizontal, then I'd be able to tell that above it is going to be on this side of the line. And you could test a point as well if you wanted to pick a point and test it. A real easy point that's clearly above the line is 0, 0. If I plug 0 in there, I would have 0 is greater than or equal to 0 minus 5 is negative 5. Yeah, 0 is greater than negative 5. So yeah, that's where I want to shade. I want my solution, my true statement, to be in that shaded region. And for part D now, this is in standard form. I'm going to have to put it in slope-intercept form so that I can graph it. So I'm going to subtract my 4x. So I'll have a negative 4x plus 24. And I have to divide everything by 3. So I'll have y is less than negative 4/3 x plus 8. So I'm going to start at 8 on the y-axis. I'm going to go down 4 and over 3. Down 4 and over 3. 1, 2, 3, 4. Whoops, 1, 2, 3, 4, and over 3. There we go. Now again, I need to look at my inequality sign to figure out what kind of a line I need. It's just less than, so I'm going to make a dashed line. And then since it is less than, I want to shade below. Now again, if I could take this line and kind of rotate it so that it was horizontal, below it would be on this part of the line. So kind of visualize rotating it so it's horizontal and then rotating it back so you can shade appropriately. And that's best demonstrated in class when you can see that. I can't really demonstrate that on the Smartboard software here. Okay, and again, if we wanted to pick a point to test, okay, 0, 0 is again clearly on one side of the line or the other. So if I did 0 is less than, say, negative 4/3 times 0 is 0, plus 8 is 8. 0 is less than 8. Yes, it is. So that's definitely where I'm going to shade from. Okay. So here's the problems that you can practice. Make sure that you have graph paper. You will need graph paper for this section. And you might have to show your work to solve the equation for y so you can get it into slope-intercept form. So make sure you're showing all your work. And if you have questions, come on in and see me before school.